with vectors for this code is to index into them. So we want to safely take elements out of a vector. And so we need some notion of number smaller than another number, smaller than the length of the vector in this case. We want to be able to be sure that the index provided by the user is less than the length of the vector. Because again, in Haskell, we can do 1, 2, can demand the fifth element of this list, and it's going to index to large, right? We want to avoid these situations. And there are many ways to go at this, but I think that the best way is to define another data type that expresses the notion of a number smaller than some other number. I'm going to call this fin, again following the naming conventions that are already there. And this fin, like vectors, is going to be indexed by a natural number. This number expressing the upper bound, the strict upper bound that we have. So fin, if we've got fin n, we want it to be the type of numbers less than n. And again, this is a dependent type in the sense that we've got a value here. Now, what is 0 less than? Well, 0 is less than anything apart from 0 itself. So we can use the same trick that we use with head and force the index to be a successor of something. If we've got an existing fin n, so we've got a number that we know is less than n, what's the biggest such number? N minus 1. If we take the successor of n minus 1, we're going to get n. So to make sure that the index is indeed greater than all the possible numbers here, we're going to increment the upper bound here, and we're going to be safe. So, for example, well, I mean,